Hi guys! Welcome to the second lesson in Unit 7, Climate Change and Energy Production. In this lesson, we are going to talk about the causes and impacts of climate change. And as part of talking about the impacts, we are going to talk about human attempts to either mitigate climate change or adapt to climate change. So if you're following along in the textbook, you'll notice that this is 7.2 and 7.3 all rolled into one. So let's get started. The first thing that we need to do to talk about climate change is define what we mean by climate and what we mean by weather. So the weather is something that happens on a day-to-day basis. The weather is when you walk outside and say, oh, it's hot, oh, it's cloudy, oh, it's whatever. And people have the ability to forecast weather relatively accurately up to about 10 days out. Climate is looking at long-term weather patterns. And the idea that climate change is occurring is the notion that when we look at the long-term weather patterns seem to be changing. And this is something that happens not irregularly in the history of the planet. It is the first time that it's caused by anthropocentric activity, by the activity of organisms that are living on the planet and not by a natural disaster. But the climate changes all the time over the long-term history of the planet Earth. And when we talk about climate change, that's all that we mean. The general climate is controlled by a few things in the atmosphere. So let's take a minute to talk about greenhouse gases and the greenhouse effect. Because the regular greenhouse effect, what is drawn out on this diagram here, is vital to life on Earth. The idea that we have an atmosphere with substances in it that trap some of the heat that comes in from the sun, that's the thing that allows us to live here. And there are some of the greenhouse gases that are able to do this are outlined over here. Carbon dioxide is the one that's been studied for the longest time. There's also methane, nitrous oxide, CFCs, and ozone. All of those have different global warming potentials, and this is the amount of heat that they're able to trap. As you can see, ozone and CFC have global warming potentials that are insanely high. Carbon dioxide is sort of the measuring stick. Methane is not too bad, and nitrous oxide is high, but not compared to these two. Greenhouse gases contribute not only to normal greenhouse effect under normal climatic conditions, but also to what we call enhanced greenhouse effect as we artificially alter the amount of the concentrations of different greenhouse gases in the atmosphere. So we are enhancing the normal greenhouse effect by putting more carbon dioxide and more methane and more nitrous oxide than normal into the environment. Some people say that there is a climate change debate, and I've left this slide blank because there's not. The idea that people would believe that there is a climate change debate, I think, is a fault of the mainstream media, making it seem like less than 1% of the scientific population has a legitimate voice in creating this debate. More than 99% of reputable climate scientists agree that climate change is occurring. The thing that you can debate is if it is human-caused or if it is natural. Because naturally in the history of the planet, there have been these changes of carbon dioxide concentrations in the air. The thing that it's harder to debate is as these carbon dioxide concentrations change, that temperature seems to fluctuate along with them. So whether it's natural or anthropocentric, we should be getting ready for temperature changes and questioning what those temperature changes will do to our environment. And the next slide addresses some of the things that might happen. So when you look at impacts of climate change, you can break it up system by system and look at some of the things that are likely to happen and what that might mean in different areas. So in oceans, as temperatures increase, sea levels will rise. There's also the concern that as oceans get hotter, carbon dioxide that is stored deep in the oceans will be released and be released quickly. And this could lead into a positive feedback loop that we will discuss on the next slide, but keep that in mind. The same thing in the ice caps. They will melt, obviously, as temperature rises. But under that ice is a big storage of methane. And as that methane is released all at once really quickly, that could lead into a positive feedback loop, a new state of equilibrium for our planet. The impacts of climate change, and by climate change, we generally mean increasing temperatures overall, and increasing amounts of energy in the atmosphere, which leads to things like weather patterns changing. The impacts of climate change in a variety of ways are listed out here. But what is certain is that this change in temperature and energy in the atmosphere will have a lot of effects on human populations. So people are interested in figuring out what those effects might be. For that, we turn back to modeling. And when we remember, a model is a diagrammatic representation of things that are happening around you. We learned about that back in chapter 1. When we look at climate change, since there are so many intricately connected systems, it's hard to predict exactly what might happen. You can have models of climate change that show negative feedback, where outputs return as stabilizing inputs, or models of climate change that show positive feedback, where outputs return as destabilizing inputs, leading to a tipping point and a different environment. So looking at this question of carbon storage in the oceans, for example, you could have carbon storage in the oceans, and we do have that. There's a significant amount of carbon stored in the ocean. As temperature increases, you could make the argument that maybe algae in the ocean will also increase because they'll grow faster in a hotter temperature. And then as that algae increases, it will store more carbon dioxide, CO2 store, and that will lead back into a normal situation of carbon dioxide stored in the oceans. You can also make the argument, though, that as carbon dioxide is stored in the oceans, as we said, we have increasing temperatures. Those increasing temperatures might get too hot and kill off the algae. And in that scenario, nothing would be neutralizing the changing levels of carbon in the atmosphere. So increasing temperatures, decreasing algae. This does not circle back around. There's decreasing carbon in oceans and increasing carbon in atmosphere. Decreasing carbon, oceans, increase atmosphere, and then you see that effect of an increasing temperature get more and more and more significant. So when you look at models for climate change, it remains pretty uncertain exactly what's going to happen. But one thing that we can say pretty much for sure is that humans are going to have to both mitigate and adapt to things that are happening with climate change. So when we talk about mitigation, we mean trying to reduce the effects of climate change. So reducing greenhouse gases in the atmosphere is our best bet at this. And there's 4 main things we can do. We can reduce our energy consumption because then the greenhouse gases won't be emitted. We can actively take carbon out of the atmosphere with technology. We can take carbon out of the atmosphere with trees. Or we can start to engage in what people call climate engineering, where you're artificially manufacturing and manipulating the climate with things like cloud seeding and mirrors that you shoot up into outer space to deflect sun rays. So those are all mitigation strategies. Adaptation strategies are the things that we do to adjust human or natural systems in response to actual or expected climatic stimuli and effects. And there are 5 things that we can do here. We can build to resist flooding. We can change agricultural production, both what we grow and where, to suit the new biome distributions that will happen as a result of increasing temperatures. We can try to manage the weather through programs like, again, cloud seeding and shooting up mirrors into outer space to reflect off sun rays. We can deal with human migration attempts, and we can vaccinate people better because as temperatures increase, mosquito-borne illnesses increase also. So how to deal with climate change, both as a national and international community, has generated some interesting legislation. There are some examples of important international agreements that have happened here. The Intergovernmental Panel on Climate Change in 1988 was what established the UN Environmental Program, and they sort of keep an eye on climate issues. The Kyoto Protocol in 1997 was the first time that we really tried to limit carbon dioxide production globally. And the Paris Agreement just 2 years ago was when the United Nations countries came together to say that we were going to cap global warming at 2 degrees. Unfortunately, this sort of fell apart when the United States pulled out of it in November of 2016. But it had looked for a long time before that like it was going to be a really significant human-based effort in managing climate change. And that's actually what you're going to look at in your homework. Is if you're following along in the reading, again, this is 2 sections of the textbook, so there's a lot of reading. There are a lot of big sort of temperature diagrams and pictures, so it's not as long as it sounds. But for your comprehension question, you are going to do a paper 2 part B section C, and the prompt that you are going to respond to is, to what extent do humans have the ability to manage the effects of climate change? So remember, you need to write that as an essay, introduction, argument, counter-argument, conclusion. Use specific examples, use good course vocabulary, make an attempt at that, and when you are ready, check your work in the review lesson. And I will see you there.